8.2 notes, graph of the other trigonometric functions. This is page 8. If you take a look at the notes, this is also page 7, so don't stress out if the numbering's off. For some reason, this page got copied twice. And so here's your super fancy recording with sound. We are going to start analyzing the graph of the secant function the same way we just did on page 6 with the cosecant. We're going to start by graphing the cosine function. And so let's start by filling in the table. At negative 2 pi, our cosine is 1. Negative 3 pi over 2, it is 0. At negative pi, it's negative 1. Negative pi over 2, it's 0. At 0, it's 1. At pi over 2, it's 0. At pi, it's negative 1. At 3 pi over 2, it is 0. And at 2 pi, we're back at 1. And so I'm going to set this up and graph it the same way we just graphed the sine. Negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, 0, 1. And then we're going to graph our cosine function. So we know we're up here at 1 at negative 2 pi, at 0 for negative 3 pi over 2, negative 1 at negative pi, 0 at negative pi over 2, 1 at 0, 0 at pi over 2, negative 1 at pi, 0 at 3 pi over 2, and 1 at 2 pi. Awesome. And so we get our cosine function. I think as many years as I've been graphing, it'd be a little cleaner than that, but you guys know what we're looking for. Okay, so secant. Secant is 1 over cosine. And so we're going to have the same problems we had with the sine. We are going to get an undefined value wherever our cosine is 0. And then it's going to share that maximum for the cosine. So, yeah, we're just going to do the exact same thing we did a minute ago. Anywhere my cosine is 0, I have an asymptote. So I'm going to start by drawing those in. Even this messy spot, I know where that 0 is supposed to hit. And then it shares the maximums and it shares the minimums of the cosine function. Okay. And so cosine and sine are related, cosecant and secant are related. So this is going to do the same thing that the cosecant function did, and that is from the maximum and minimums, we are going to approach those asymptotes. And again, this bit in the middle, not part of the graph. We're just using that cosine for reference. So our domain, all real numbers. So let's take a look at where we've got those asymptotes. So I've got an asymptote here at x equals pi over 2, x equals 3 pi over 2, negative pi over 2. So we have asymptotes at the pi over 2's, but not all the pi over 2's. The even pi over 2's are left out because 2 pi over 2 would be pi, and that's not one of our asymptotes. And so we've got to be kind of specific here. Our asymptotes are at x over 2 times k This time k has to be an odd integer. Our range looks the same as with cosecant. We're going to go negative infinity to negative 1. And then 1 to infinity. Our period mirrors the period of cosine, so that's 2 pi. Again, we have no amplitude. The equations of our vertical asymptotes. So with a translated function, you'll see pi, that's not a pi, pi in the numerator, over 2 times the absolute value of b, times k with k an odd integer, in this case, because b is 1, our asymptotes are at pi over 2k, where k is an odd integer. Okay. This book and these materials really likes giving you formulas. If you understand what's going on with the sine or cosine, it's fairly easy to graph the cosecant and the secant.